States and properties of matter. So we talked about how matter is anything that has mass and occupies space. It is all around us. We talked about how we classify it into two groups: pure substances, either an element or a compound; mixtures, homogeneous solution, or heterogeneous. So then we go a little bit further into talking about how they exist, how matter exists. Matter exists in three forms: solid, liquid, and gas. Solids have a definite volume and shape. So basically, if we have a solid, my particles of my solid are really, really attracted towards each other, hanging on super, super tightly. Definite shape, definite volume. So if this was a 15 milliliter ice cube in this flask, and I were to put it in a beaker, it would still be 15 milliliters, and it would have the same shape. It wouldn't change because the particles are so attracted towards each other, they're staying close together and not changing the shape based off of what container they're put in. Now, a liquid has a definite volume, but a variable shape. So what that means is the volume, the amount doesn't change, however, the shape changes. So if I were to take this 15 milliliter ice cube and put it into a flask, and I melted it into liquid, it would take the shape of the flask. Now, if I took that into a beaker, it would take the shape of the beaker. It would still be 15 milliliters. If you would pour it on the surface of your table, it would also still be 15 milliliters, but it would take the shape of the table. So the amount never changes, but the particles are a little less attracted towards each other, so they have more range of motion, freedom of movement, to kind of take shape the container that they may be in. Then gases have variable volume and variable shape. And what that means is they take the shape of the container they're in, and they're all over the place. They're not attracted towards each other, and they lose the volume. Now here you can see that there's a little cork on top of the flask to contain the gas, but it's all over the place. The particles are not attracted towards each other. They don't want to be close together. They're losing the amount that they have because they're escaping, and they take the shape of whatever container they're in. So one way to describe matter is to observe the properties. So we like to look at two types of properties: physical and chemical. Physical properties are those characteristics that can be observed or measured without affecting the identity. So it's just something that you can, let me write that down. You're not affecting the identity by noticing this. So it could be the shape, color, melting point, boiling point, any physical state of a substance, solid, liquid, gas, etc. Odor, the color, anything like that. When matter undergoes a physical change, its state, size, or appearance will change, but its composition remains the same. So no change in composition. What that means is it's not changing what it's made up of, but it may look different, or it changed its size, but you didn't change what it was made up of. Now, the other thing that we look at is chemical. So chemical properties are those that describe the ability of a substance to change into a new substance. So then a chemical change takes place when the original substance is converted into a new substance. So it has a change in composition. So a great example is right down here. For example, when you have a pot with just water in it and you're boiling the water, eventually your water is gone and you just have steam. Now, you didn't change that it's water. It's still water, but you changed the shape, the state. It went from a liquid to a gas. So that's a physical change. Whenever you're just changing the state of matter, going from an ice cube to water, water to steam, or vice versa, you're not changing what that's made up of. You didn't react it with anything. You just changed its state. So it's physical. Burning a candle. If you burn a candle, you've added fire to that. It's reacted with oxygen and it began to melt. You can no longer go back to the original candle because the wax of the candle took in the energy of the flame and then the oxygen around reacted to it. So it's a chemical change. Another good example of a chemical change is when you have a nail out in air for a while. What happens to it? It turns into that yellowy rust, brownish rust. That's a chemical change because it's no longer the iron metal. It's iron oxide. Because it reacted with the oxygen, you can't go back anymore. Okay, so let's practice a little bit. Indicate whether each of the following describes a gas, liquid, or solid. The breathing mixture in a scuba tank has no definite volume or shape. Now, is that a gas, liquid, or solid? No definite volume or shape is a gas. The neon atoms in a lighting display do not interact with each other. So it can't be a solid because they're really, really attracted towards each other. The neon atoms in a lighting display do not interact with each other. But because they're in a container, what are we thinking here? The particles in an ice cube are held in a rigid structure, so that is for sure a solid. So I'm going to say B is a liquid because it doesn't give us too much information for it to be a gas. Classify the following as a physical or chemical property. Chromium is a steel gray solid. You are just simply describing the color, so that would be physical. Hydrogen reacts readily with oxygen. You're telling me, or we're reading, that this is a reaction. This is usually how it reacts. So that's a chemical change. A patient has a temperature of 40.2 degrees Celsius. So you're still just describing the state of the patient. So it's physical. Milk will sour when left in a warm room. Well, if milk is left in a warm room, the reason it sours is because it reacts. So that's chemical change. All right, last one. Classify the following as a physical or chemical change. Water vapor condenses to form air. Basically, liquid water to gas. Is that physical or is that chemical? Physical. Cesium metal reacts explosively with water. It's reacting, wouldn't go back to it, chemical change. Gold melts at 1064 degrees Celsius. Now you're adding in the energy, you can't go back to gold, so that would be chemical. A puzzle is cut into 1,000 pieces. Well, you didn't change the composition of the puzzle, you just changed what it looked like, so that's physical. So knowing that if you are not changing the composition, you have a physical property, physical change. If you are changing the composition by it reacting with something like a flame, oxygen in the air, or other components, it's chemical property, chemical change. Solid, liquid, and gases, the way that we look at those are solids are really attracted towards one another, rigid, they have a definite volume and shape. Liquids begin to have a little bit more freedom of motion. They take up the container they're in, but they're still fairly attracted towards one another, keeping that same volume. And gases don't want to be close together at all. They don't have a definite shape